All right, we're going to be working with exponents. So when the numbers have the same base, the base is going to continuously go into the answer. So the answer is going to have 3 as the base as well. But if you're multiplying, the exponents are going to be adding, causing the final answer to create an equivalent expression to be 15. Okay, these two are adding. Okay, let's do it again. So 4, 4. So this is going to be 4. Okay, and then the exponents are going to add, causing it to be 7. Then here, so here, the exponents are the same. So if the exponents are the same, the exponent's going to stay the same, but the numbers at the bottom are actually going to multiply. So that causes the final answer to be 12. So exponents always do an easier step than what it's assuming you to do. So if you're changing the exponents, you're always going one step lower. So what's easier than multiplying? It causes it to be adding. Okay, here the bases are changing and they actually do what it says. They multiply. So here again, the exponents are the same, so it's going to stay the same. The bases are different, so they're going to just multiply like it says. Okay, so let's go to the next one. So when an exponent has an exponent, okay, I'm going to change the exponent, meaning we're going to go one step lower. What's one step lower than exponents? Multiplying. So this is going to be 5 to the 12. See me do it again. So 3 to the power of 8 to the power of 3. So these two are going to multiply and cause it to be 3 to the 24th. All right, here we go. So how do you do a fraction when it has an exponent? Well, it causes the 2 to be cubed and the 3 to be cubed. Okay, so our final answer is 2 times 2 times 2 and 3 times 3 times 3. So it's going to be 8 over 27. This one here, we're going to do it again. This causes the 1 to be squared and the 5 to be squared. So that's going to be 1 times 1 divided by 5 times 5, which would just be 1 over 25. All right, so any number except for 0 to the power of 0 is 1. So 18 to the power of 0 is 1. 218 to the power of 0 is 1. 1,218 to the power of 0 is 1. 121.8 to the power of 0 is 1. Okay? If I do 0 to the power of 0, then yes, that equals 0. But that's just the exception to the rule. All right, so let's keep on going here. All right. Now, I'm going to be doing this one here. So if you multiply and the exponents are changing, then you add. So when you divide, same rules, but division is the opposite of multiplication. So yes, the 7 stays the same, but instead of adding, these exponents are going to subtract, causing it to be 5. Okay, here, same thing, we're dividing. The bases are the same. So the exponents are going to subtract, causing it to be a 3. All right, here we go. So let's do this one. So a negative exponent means that everything's on the wrong side of the fraction. So let's actually solve this now. So I'm going to get rid of the negative number first. So this is going to cause it to be 5 over 7. And it's still 11. So now the negative went away. The negative exponent went away because now everything is in the correct spot. Okay? The negative exponent is kind of yelling, everything's in the wrong spot. This is in the wrong spot. Everything in this parenthesis is in the wrong spot. Okay? So now that I have fixed it, I can now do the work. So now I'm not going to do 5 to the 11th power, but I'm going to show you how to write it as an equivalent expression. Okay, so this is equivalent to those. So let's do this one here. So remember, when you're multiplying, these are adding, right? So -5 plus -2. So this double sign, the 2 has 2 signs in front of it, this will become a minus sign. So it's going to be negative 5 minus 2. So my final answer is negative 7. So 8 to the power of negative 7 is the same as this. Or, because I have the negative sign, let's pretend you have to leave it as a positive. This will cause this to turn into a fraction. So, Mr. Castro, how is this on the wrong side of the fraction? Well, there is an imaginary 1 down here. Okay? So I'm going to flip this, causing the 1 to be on top and 8 to be on the bottom. Okay? Oh, actually, it should be positive now because I actually did put it in the right spot. So that's my final answer here. Okay? So here, negative 5 and the 2, you're dividing, so they're subtracting. So the negative 5 is subtracting 2, so we're going to be left with negative 7. So the answer is 7 to the power of negative 7. Or if you wanted to leave it with a positive exponent, it would be 1, 7 to the power of 7. Here's another example. Okay? 5, the answer to this is 1, 5 to the third power, or 1 over 125. I'd be happy with any of these two. And then that's it. I guess if I have something like this, 1, 3 to the negative 2, you can fix this and cause it to just be 3 to the power of 2. Okay? That's it.